Less total space is required in a storage system that uses a randomized storage strategy. On the other hand, dedicated storage requires space for maximum inventory level of each item. However, high throughput rates are achieved in a system that uses dedicated storage strategy based on activity level, where the most active item can be located near the input and output points. However, there are some compromise, especially for class-based dedicated storage, where items are divided into classes according to activity level and random storage strategy used within each class. There are several methods for conventional storage. The first one is called bulk storage, where the storage is conducted in an open floor area. So one of the problem for bulk storage is on achieving proper balance between storage density and accessibility. This is an example of a bulk storage methods where the materials are just stored in a bulk manner. The second one is the rack system, where it uses structure with racks for pallets loads, and this permit vertical stacking of a material. The third method is by using shelving and bins, where horizontal platforms in structural frame are used. Still, shelving comes in standard size, and finding item can still be a bit problematic. The third and the last one is the final storage, where entire content of each drawer can be viewed. However, this is normally limited by the size of the material that we are going to store. This is an example of a bulk storage, where in figure A, the bulk storage arrangement is in high density that provide very low accessibility. And for figure B, the bulk storage with load forming rows and block for improved accessibility, where operators and forklift may use the aisle to access the middle of the storage. And normally for bulk storage will have a good impact on the low cost per square meter. The second type is the pallet rack system. So pallet loads are placed on racks in multi-rack structure. Because this system effectively use the vertical space, we can achieve a low cost storage for each of the item, and we can also achieve good storage density and good accessibility. This is an example of a drawer storage where content can be easily visible. We have good accessibility, relatively high cost, and normally it is constrained for small items only. Okay, due to advancement in technology, nowadays in factory we already have several options for automated storage system. The system is mechanized and automated storage equipment to reduce the human resources required to operate a storage facilities. However, it requires significant initial investment, and it includes not only in terms of the storage equipments, but also in terms of factories. There are several levels of automations. In mechanized system, an operator participates in each storage or retrieval transaction. However, in the end of the high spectrum, the loads are entered or retrieved under computer control. These are the normal objectives and reason for automating storage operations: to increase storage capacity, to increase storage density, to recover factory floor space currently used for work in progress, to improve security and reduce pilferage, to reduce labor costs and increase productivity, to improve safety, to improve inventory control, to improve stock rotation, to improve customer service, and the most importantly, to increase the throughput system. There are two types of automated storage system. The first one is called Automated Storage and Retrieval System, ASRS, where it consists of rack system with mechanized and or automated crane to store and retrieve loads. The second type is called carousel storage system, where it utilizes oval conveyor system with bins to contain individual items. Let us see some of the example.
India's largest selling spice brand, Everest, has set up a new manufacturing unit at Umbergaon in Gujarat. The 50-year-old company manufactures a range of 45 products, both blended and pure spices, for which it requires 60 types of raw materials from different parts of the country. To cope with the storage problem of perishable material, the company chooses Japan's Daifuku for a complete warehousing solution. Everest has plans to produce 400 tons of spices every day from the new facility and requires storage of 1,200 tons of raw material.